Hello, math friends. Today we're going to go ahead and talk about how you identify translations. When I think about translations, I think about how this SL is hidden in the word translation, and it's my hint that this is just like describing slides in elementary school. We're just going to sophisticate it a little bit to the middle school level, but let's just start with what we used to identify slides with. If I were to start with the blue star and I move to the red star, how would I say I travel? If I look from A to A prime, it looks to me like I'm moving to my right and then I'm moving down. And sure enough, if I look at the C, I go to the right and down, or the B, right and down. So the star is moving to the right and down. That would be how I used to describe it. But now I'm going to go ahead and use my coordinates, my X and my Y, to describe it. And I'm going to think about how when I move to the right on the coordinate plane, it's a positive direction. And when I move left, it's a negative direction. And I'm going to think about my Y, that when I go up, it's positive, and when I go down, it's negative. So if I start with my A coordinate and I want to move to the right, how many? 1, 2, 3, 4, 5. So I would think that I took my X coordinate and I added 5 because I moved to the right, which is a positive thing, 5 spots. If I think about how I went down, I went 1, 2, 3, 4 down. So I took my Y coordinate and I subtracted 4. This is describing the translation using coordinates. And so if I check, if I look at B, it's not right on the intersection of grid lines. Neither is E. So these aren't great points to check with. They're harder to count. So let's try C. If I look at the movement of C, did it do the same thing? I go 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4 down. Sure enough, and let's check E just to super make sure. 1, 2, 3, 4, 5, and down 1, 2, 3, 4. It looks like it turns out perfect. This is describing the translation using coordinates. There's one other way I could check. I could take a look at what is the ordered pair for point A. If I start on my origin, it looks like I move 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6. So I'm at -5 because I went to the left, -5, 6. Now if I apply this rule that I think is how my star moved, it should give me the coordinates to A prime. So if I add 5, or I fill my -5 in for my X, I'd get -5 plus 5. And I fill my Y value in for the Y, I would get 6 minus 4. If I do the math, -5 plus 5 gives me 0, and 6 minus 4 gives me 2. So this should tell me that if A was here, A prime should be at 0, 2. Let's see. If we start here, I don't go right or left at all, and I go up 1, 2. Sure enough, woohoo! I landed on A prime. So this is a good check. But this right here is my answer of how I describe the translation using coordinates. Let's try one more time over here. Again, remember I'm moving from blue to red. If I look at from A to A prime, what direction am I moving? I'm moving to the left, and I don't go up or down at all. So that's interesting. It's like I'm just doing something to my X coordinate. So if I start at A, how far to the left do I go? 1, 2, 3, 4, 5, 6, 7. It looks like I moved 7 to the left. So that would mean I took my X coordinate and I subtracted 7. And my Y coordinate, I didn't move up or down, so it stayed exactly the same. Let's see if the same is true for my B. So if I start at B and move to B prime, I go 1, 2, 3, 4, 5, 6, 7. Sure enough, I again move 7 to the left. Let's do our check. My A coordinate looks like it's at 1, 3. And again, this is just my check. 1, 3. And so I fill it in for my X. I do 1 minus 7, and then my Y would stay the same. 1 minus 7 would give me -6, 3. So let's check it. If I go to -6, 1, 2, 3, 4, 5, 6, and up 1, 2, 3. Sure enough, I land at A prime. Super awesome. So if I were to look at my answer again, it is x minus 7 comma y. That's describing the translation using coordinates. You are ready, mathematicians. Go identify those translations.